So, what could scuba diving, a bag of chips on an airplane, and the very act of you breathing right now possibly have in common? Well, they're all run by one simple, really elegant rule in physics: Boyle's law. It sounds kind of technical, right? But stick with me, and I promise you're going to see this simple rule in action literally everywhere. All right, so let's kick things off with a little mystery. You've probably seen this in a movie or a documentary, right? A scuba diver breathes out and you see these bubbles, but as they float up to the surface, they get bigger and bigger. So what's going on there? The answer is actually the key to understanding a whole bunch of stuff we see all the time. So here's our game plan. We're going to tackle that scuba question head on. Then I'll introduce you to Boyle's law itself. We'll look at the super simple formula behind it, check out some really cool real-world examples, and then we'll even put it to work ourselves. Okay, first up, the pressured question. So that whole mystery about the expanding bubbles, turns out the answer isn't just hiding deep in the ocean. Nope, it's happening all around us all the time. I mean, really think about it. You ever been on a plane and noticed your bag of chips looks like it's about to explode? It's all puffed up. What could that possibly have in common with scuba bubbles? Or, that little pop sound when you open a jar of jam for the first time? You wouldn't think these things are connected, but they are. They're all showing us the exact same scientific rule in action. So, what's the big secret? The one thing that connects all of this is something called Boyle's law. It's the simple, elegant rule that's going to solve all these little mysteries for us. Okay, so let's get the official definition out of the way. Boyle's law says, for a fixed mass of a gas at a fixed temperature, pressure and volume are inversely proportional. I know, that sounds super sciencey and maybe a little intimidating, but don't worry. Inversely proportional is just a fancy way of saying something really, really simple. So what does it actually mean? It just means they're opposites, like a seesaw. When one goes up, the other has to go down. So if you crank up the pressure on a gas, its volume shrinks. And if you lower the pressure, its volume expands. Simple as that. They always move in opposite directions. Here's a really easy way to picture it. Just imagine the gas particles are a bunch of people in a room. If you cram 100 people into a tiny little closet, right? The pressure is super high, everyone's bumping into each other, and there's basically no space or volume for anyone. But now take those same 100 people and let them loose in a giant gymnasium. Suddenly the pressure's way down, and everyone has a ton of space to themselves. See? High pressure, low volume. Low pressure, high volume. Okay, so we get the idea, but how do we actually calculate this stuff? Well, this is where science uses its favorite language, math. And lucky for us, the formula for Boyle's law is about as simple and powerful as it gets. And there it is. P1 times V1 equals P2 times V2. That's it. That's the whole shebang. It looks so simple, but with this little equation, we can predict exactly what happens to a gas when we start changing things. So what do all these letters and numbers mean? Just think of it like a before and after picture. The little ones, P1 and V1, that's your starting point. That's the initial pressure and the initial volume. And the twos? Well, that's your aftershot, the final pressure and the final volume after you've made a change. All right, theory's done. Now for the fun part. Let's go see this law out in the wild, in the real world. This is where it's all gonna click into place, I promise. And we're back to our scuba diver. So as that bubble travels up, there's less and less water pressing down on it, right? The weight of the ocean above it is decreasing. So the pressure, our P, is going down. And what does Boyle's law tell us? If pressure goes down, the volume, our V, has to go up. And boom, that's why the bubble gets bigger. Mystery solved. How about a syringe? Think about what happens. You pull the plunger back. What are you doing? You're increasing the volume inside the barrel. So Boyle's law kicks in, and the pressure inside the syringe drops way down. Now you have low pressure inside and higher pressure outside in the liquid. While nature doesn't like that imbalance, so the higher pressure liquid just rushes in to fill the space. It's not magic, it's just Boyle's law. Seriously, once you know what to look for, you start seeing this everywhere. The fact that you're breathing right now, that's Boyle's law. Your diaphragm moves down, increases the volume in your chest, the pressure drops, and air rushes in. An aerosol spray can? High pressure inside, low pressure outside? Shh. A bicycle pump? You're just squishing a large volume of air into a small volume to jack up the pressure and force it into the tire. It's all the same principle. Okay, so you get the concept, you've seen the formula, now it's time to actually put it to work. Let's roll up our sleeves and solve a quick problem together. You'll see, it's not that bad. So here's the problem. We've got a gas that takes up 12.3 liters at a pressure of 40 millimeters of mercury. The question is, what's the new volume when we crank the pressure up to 60? Now, just based on what we've learned before we even do any math, if the pressure is going up, what do you think is going to happen to the volume? It's got to go down, right? The answer is 8.2 liters. Just like we thought, the pressure went up and the volume went down. But how do we get that exact number? Let me show you the steps. It's a super simple 4-step process. First, just list out everything you already know. We have our starting pressure, our starting volume, and our final pressure. Easy. Second, write down the magic formula. P1 V1 equals P2 V2. Step 3, you do a tiny bit of algebra to get the thing you're looking for, in our case V2, all by itself on one side of the equation. And finally, step 4, you just plug in the numbers you know and let your calculator do the heavy lifting. That's it. So let's just wrap this all up. What are the big takeaways? First, Boyle's law is all about that inverse relationship between pressure and volume. Remember the seesaw, when one goes up, the other must come down, as long as the temperature stays the same. Second, that little formula P1V1 equals P2V2 is your superpower. It lets you calculate exactly what's going to happen. And finally, this isn't just some abstract idea. It explains real stuff, from deep-sea diving to how medicine works. And that's Boyle's law. So I'll leave you with a question. Now that you have this new way of looking at the world, what other things can you suddenly explain? What about the fizz when you crack open a can of soda? Or how a suction cup sticks to a window? The physics is happening all around you. Now you just know what to look for. Thanks for joining me.